Hey everyone, it's that math magician. On this video, we're going to take a look at probability and we're going to learn exactly what permutations are, how we can use them, and while the word might sound scary, it's actually a nice formula that we can use to help us solve these problems out. So let's jump right into this problem where we have permutations, and notice that I wrote right there that order matters. This is super important when we're thinking about what a permutation is. When you're given a probability question where you're picking things, you're choosing, oh, I want this, I want this, I want this. The order that you choose them in is going to matter. That's what you call a permutation, where I want this thing first, I want this thing second. That's what a permutation is. And the best way to really show you what a permutation is, well, to just look at an example problem, such as this problem here. Trying to create a 4-digit PIN. Again, we're thinking about that ATM card. I'm trying to create my 4-digit PIN using the numbers 0 through 9, and I'm not going to repeat a number. Okay, we're not repeating a number here. This is a great example of what a permutation is because the order here matters. Think about having a 4-digit PIN when you walk up to the ATM. Let's say your 4-digit PIN was 1, 2, 3, 4. Super simple. Hopefully no one's out there is 1, 2, 3, 4. But if that's what it is, that is your PIN. You cannot walk up to the ATM, put your debit card in, and type in the number 2134. That won't work, right? It'll spit it out and say you entered the wrong PIN because the order matters. That's what a permutation means. The order matters when I'm selecting those numbers here. So we want to figure out what are all the possible combinations here for a 4-digit PIN. I'm sorry, not combinations, all the permutations for this 4-digit PIN using the numbers 0 through 9 without repetition. Now, some of you out there might be thinking, oh, decision chart time. And that's a good idea. Let's use a decision chart for this, right? I have my 4 digits that I'm picking from, right? The first option, I'm going to have 10 numbers to choose from. Be careful, it's not 9. It's 10 because I'm including 0 here. So if we think about counting on your fingers here, right, we're going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 numbers to choose from. Every time I pick a number, it's going to drop, right? We're saying no repetitions allowed. So that number is going to drop then to 9, then to 8, then to 7. I think we know the drill by now. Get that calculator out. Come on, Mr. Calculator. There we go. And let's type it in. 10 times 9 times 8 times 7. That gives us an answer of 5,040 different ways to create this PIN. Okay, that is how you can do a permutation. But there is another way that we can accomplish the same thing using what we know are as factorials. Okay, that's why we learn factorials. They're actually very helpful for us when we talk about permutations and later when we talk about combinations. Because this here actually looks like a permutation, doesn't it? Like, look at that decision chart there. It sort of looks like that I have 10 factorial, right? We know 10 factorial is 10 times 9 times 8 times 7 times 6 going all the way down to 1, right? But it looks like I've kind of chopped it off there, right? I haven't included all of the numbers in 10 factorial. I sort of removed the parts that I don't want. And so what we can actually do is we can make this into a fraction where I have 10 factorial on the top because I'm choosing from 10 different numbers. But I'm actually going to remove 6 of the factorials on the bottom, right? 6 factorials taken out. I do not include that in my final answer here. It is missing because I only want 4 digits. I'm only taking the first 4 numbers. And so we end up with 10 factorial over 6 factorial, which, if we get our calculator out or if we try to just do it by hand, we would end up with that same number of, right, I can do this again to show you, 10 times 9 times 8 times 7 times 6, right? That would keep going on forever. That would also go down to 1. We know from our last video that those will cancel, and so we're left with just 10 times 9 times 8 times 7. We end up with 40 ways of doing it. Now, some of you might be thinking, why the heck are we creating this fraction out there when I can just make my decision chart? And you're right, we could do a decision chart for this problem because this is a relatively easy problem for us to look at. But if we have a much larger problem where I'm not picking 4 numbers, maybe I'm picking 10, 20, 50, it starts to get a little more complicated. And that's why we want to think about using factorial fractions to help us solve these permutations. And before I move on to another example, I just want to show you real quick, there's some notation for this. The notation for this is going to be a capital P for permutations. The number you put in front represents the number of items you're choosing from. We had 10 numbers to pick from, right? 10 numbers to pick from. So I'm going to put a 10 right there. The number I put off to the side, the right side, is how many I'm picking. Think about that again. 10 numbers that I'm choosing from, but I'm only picking 4. This is how you write out a permutation, okay? 10p4 would give me 10 factorial over 6 factorial, which ends up just being 5040. Okay, let's try another example, and let's see if we can use kind of this new way of doing it to solve this problem. Okay, I'm going to go ahead and paste. I think I had it here. Did I? I think I have to right click. Oh, there we go. Paste it down there. There we go. I'm going to scoot this over real quick. I'm going to take this example problem. We're not going to do the same one, obviously, because we'd have the same exact problem there. But what I want to do is, why aren't you letting me scoot over? We'll try it one more time before I give up here. I got to hold it like this, maybe. There we go. Let's scoot that over. And instead of having the same exact problem, I think what might be helpful is let's just kind of switch one thing about it. Okay, let's switch one thing. Maybe instead of having 4 numbers to choose from, what if our pin now is going to have 5 digits to use from? What's that going to end up looking like? Okay, this 5-digit pin using the numbers 0 through 9. Actually, let's also change this number to be a 1. Maybe we're not going to include 0. Still no repetition allowed. Let's think about writing this out as a factorial fraction. Let's not use it as a decision chart. Let's use it as a factorial fraction. So I would write this as 9 capital P. Notice I'm not using 10 now. I'm using 9 because I only have 9 numbers to choose from. Right? There are only 9 numbers there, so I can only use those 9 numbers. And how many of those 9 numbers am I choosing? Well, I'm choosing 5 of them. Okay? That's how we set up that permutation notation. Hey, that rhymed. All right, let's create our factorial fraction. Well, the number that goes on top is the 9 factorial because I have 9 numbers to choose from. Be careful here. 5 does not go on the bottom. Look at that previous number or example up there. We didn't put a 4 factorial underneath there. We put a 6. And how did we get the 6? Right? How are we getting the 6? Well, we're picking 10 numbers to choose from, right? We had 10 different numbers to choose from, but we were taking only 4 of them, right? I only wanted to pick 4. So really what we did is we took 10 minus the 4, we ended up with 6. 10 minus 4 gave me 6. So down here, I could kind of do that same logic here. I could do the 9 minus 5 because I'm picking 5 numbers. So that means we're going to want to get rid of the 4 factorial. Okay, that's how we end up working this problem out. 9 factorial over 4 factorial. Again, you can do this by hand if you want. 9 times 8 times 7 times 6 times 5 times 4 factorial. That's going to end up over here canceling out, right? We want to get rid of those 4 factorials. You can get your calculator. You can punch in 9 times 8 times 7 times 6 times 5. You'll see what that number ends up being. But what might be nice for you to understand is that your calculators actually have a way to handle factorials. If you're using this Desmos online calculator or your graphing calculator at home, you can also use factorials on there. But we got to find it. You got to go over here to the function tab. When I go over to the function tab, I see, look, right here, there is an exclamation point there. So I could actually just type this in without showing my work here. I could show that I have 9 factorial divided by 4 factorial, and it ends up showing me that we have 15,120 different ways to create that 5-digit pin, all by punching it into my calculator. I could also just do 9 times 8 times 7 times 6 times 5. I'll still get the same way, right? That's our decision chart way. That also works as well. And another thing that we can do, I don't know if you noticed here, is look right here. NPR. That is our permutation notation. Right there where I had 9P5. We could take this and we could type in those two numbers. Now, I've never used it on this calculator before, so we'll have to see. I guess if I hit 9, I hit this number. Nope, that did not do it. I think what I have to do is hit this first and do 9, 5. Yeah, that's how you do it on Desmos. See, we're learning together here. I got to type in, what was my N? It was 9. My R was 5, the number I'm picking. We end up with 15,120. Lots of ways to solve this problem out. Actually, 3 different ways. I think this way is a little easier. You just punch it into your calculator, right? All right, let's try one more example problem just like this so we can see if we're getting any better with this. Okay, let's paste in that problem we were using before, and let's switch some things about it, okay? This time, I only want a 3-digit pin, if I can write the word 3. There we go. I want a 3-digit pin, and I want to use the numbers 2 through 9 without repeating those digits, okay? Let's first set up our permutation notation. Okay, I'm going to have my capital P here. The number that goes in front of it is the number of items that I'm choosing from. In this case, I'm choosing from the numbers 2 through 9. How many numbers are there from 2 through 9? We'll count it up. 2, 3, 4, 5, 6, 7, 8, 9. There are 8 numbers to choose from. So I'm going to go ahead and punch in an 8 right here. Out of those 8, how many are we wanting to pick? Well, we just want to pick 3. So that means our factorial fraction is going to end up with an 8. Whoops. All right, computer messing up. It's all good. We'll end up with an 8 factorial on top. Again, not putting the 3 factorial on the bottom. No. How we get that bottom number is we have to take that 8 and we want to subtract it from the 3, right? Because I'm only picking 3 numbers. I want to get rid of the 5 factorial. Again, you could work this out by hand if you really want to, but I think we have lots of other ways to show it. So let's practice using our calculator. If you're using Desmos, go ahead and hit the permutation button. Type in 8, 3. That says that we have 336 ways of doing it, of creating this pin. Alrighty. Well, what if I want to do it with the factorial fraction, right? Well, I can type in 8 factorial divided by 5 factorial. And look at that. I'm still getting 336 because that's really just the formula that we're doing. Or if I want to use my decision chart, hopefully we know that that would just be 8 times 7 times 6. Okay, that is how we solve permutations. There's really 2 big things you need for this. And now might be a good time to actually write this out as a formula, right? Here's our formula. We're going to have n capital P lowercase r, okay? N here is going to represent the number of items you have. The number of items you have. Okay, in this case, we were picking from just numbers. How many numbers were we choosing? That's what n represents here. R is going to represent the number of items that you choose, right? How many are we picking? Look at that one. We wanted a 3-digit pin. Our little number R there was 3, right? Up here, we wanted a 5-digit pin. R was 5. Up here in our very first problem, the 4-digit pin gave us an R of 4. That's what R is. R is the number of items you choose. N is the number of items that you have, that you're picking from. Okay, and now we're understanding that this is really just a factorial fraction. What goes on top? Well, it's n factorial. Whatever n is, however many number of items you have, that's what goes on top. What goes on the bottom? Be careful. It's not R. It's not R factorial, but it's n minus R factorial. That right there is our formula that we want to use when we're working out permutations where we're not repeating. Okay? This is our permutation formula without repetition. As you can imagine, There's going to be a different formula for when we do allow repeating. But this right here is going to help you out when you identify that your problem has ordering, the order matters, right? Every problem we had here, the order mattered, plus there was no repetition. Alrighty guys, it's that Math Magician, and I'll see you on the next video.